Chapter 2, Lesson 2, Advanced Algebra, continuing to look at linear equations and linear functions. In this video, we want to look at the standard form of the linear equation. The standard form for a linear equation is ax plus by is equal to c. And we talked earlier about knowing what the value or what these letters represent. A and B in the standard form don't really represent anything that we can calculate. They're just numbers that we're going to have next to the variable x and next to the variable y. The letter C, however, represents a constant. A constant is just a number. The number 2, for example. The number 2 always represents 2. It doesn't represent anything else. It remains constant, therefore it's constant. Now, A and B, you can't put both of them as 0. You can have one 0, but they both can't be 0 because then this whole side would be 0 and we wouldn't have an equation. Well, we'd have an equation, but we wouldn't have anything that would be very helpful for us. Now, a couple of things, conventional things that we want to talk about standard form. If you're asked to put an equation in standard form, here's a couple of conventions that you must follow. First of all, neither A, B, nor C can be fractions. So as your final answer, none of these values, numbers that you have here, can be fractions. So you're going to have to eliminate all fractions, multiplying through by the denominators to help you do that. Okay, so that's one convention. The second convention that is that this first value here, the x term, cannot be negative. We don't want a negative number to begin our standard form. So if it's negative, you're going to need to multiply through by -1 in order to make sure that that initial term or that leading term is not a negative. So those are a couple of conventional things that you need to keep in mind when you're putting an equation in standard form. Now just take a note to recognize what standard form is. The x term is first, and there's only one of them. The y term is second, and there's only one of them. And then the constants are over here, and there's only one of them. So you'll know when you're in standard form when you have the x term first, the y term second, equals to the constant over here. If you have two x terms, you're not done because there's only one. If there's an x on this side and an x on the other side of the equation, you're not done, you're not in standard form because you got an x in both places. X is first and positive, not a fraction. Y is second, not a fraction, equals C, not a fraction. Okay, so those are some conventional things about standard form that you need to make sure that you do when you're putting an equation in standard form. Now, the thing about these linear equations that you want to look at or to make sure you understand is this. We're going to be looking at three forms: standard form, point-slope form, and slope-intercept form. And it's really important that you know what each form is, but more importantly, you need to know what each form can do for you and what each form cannot do for you. As the great Captain Jack Sparrow once said, it's not about what a man can do, it's about what a man can't do. And you really need to know what you can do and what you can't do with these different equations. Now, knowing that, here's what you can do with standard form. You can graph a line because you can figure out or determine what the x-intercept is and what the y-intercept is very quickly. That's what you can do. So with standard form, you can figure out the x and y intercepts, and because that's 2 points, and you only need 2 points to make a line, you'll be able to graph the line using the x and the y intercept. And that's what it can do. Now what it can't do, standard form, is tell you what the slope is. You remember from the previous video that the lowercase m represented slope. You'll notice that there is no lowercase m in this standard form. So when an equation is in standard form, you cannot figure out, or by looking at it, figure out or determine what the slope is. You have to change forms. You'll have to change it into another form that does have a lowercase m in it, and then you can figure out the slope. Okay? And all of these equations, standard form, point-slope form, slope-intercept form, you can change from one to the other by applying the algebra skills that you know by solving the equation for different variables. Okay? So all of them are interchangeable using algebra, but each one of them has something that it can do and then some things that it can't do. Okay? So let's see, next page. So if we need 2 points to determine a line and standard form can give me the 2 intercepts, Well, you're probably asking, how does it do that? A is not an intercept, and B is not an intercept. Okay? But you can use it to figure out the intercept, and here's how you do it. Once it's in standard form, you can substitute in 0 for x, which will make that term 0, leaving you only the by term. So then you solve the equation for y, and that will be your y-intercept. Then to figure out the x-intercept, you plug in 0 for y. That will eliminate the y term, leaving you just x. Solve for x, that's the x-intercept. So then you have your 2 points, then you graph it. Okay, so let's do a quick example. Before I do the example, let me talk about what to do with a graph. Okay, I want you to be very careful about how you graph these, and I want you to use the graph sticky notes that I have. Ask me what they are. If I haven't talked about them in class, ask me what they are. I don't want you doing any freehand graphs as part of your practice problems. I want you using these sticky notes in there because they already have the grids made up for you. However, the grids aren't marked. So here are, again, a couple of conventional things that you have to do when you're doing a graph or graphing a coordinate grid. You must label each axis, x and y. Okay, when you're doing word problems, it'll be something else. Each axis must have its own scale, so you need to put a scale on here. I would suggest only be using 2 numbers. That's all you need. That's enough for the person to know what the scale is. And then I would skip every other one when I'm labeling them to give me some room so I can see what I'm doing. So here, 1, I put the 2, 3, 4. 2 and 4 are enough to indicate what these values are going this way. That's all you need to do. But you need to do one on each axis. Okay? Now, once we have that, we can go ahead and look at our equation. Now, here's an equation that's in standard form, and we want to graph it using the intercepts. So you need to find the intercepts. So we can substitute in 0 for x, which makes this term 0, and then we solve the expression, and we have y equals 2. Y equals 2, that's the y-intercept. So this graph is going to cross the y-axis at 2. Now, because you're graphing this, I want you to put the coordinate of that point on the graph so I can see what the y-intercept is. Okay? I want the graph to show me everything about the problem that you're doing, and I'll show you at the end what it's going to look like. So you need to label that point. Then you go ahead and figure out what the x-intercept is by substituting in 0 for y. That's going to make the y term go away. 2 times 0 is 0. And then you're going to solve for x. So x here is negative 4/5. Now that's a fraction. That's okay. That's between 0 and negative 1. So somewhere about right in here is the x-intercept. I want you to label that. That's negative 4/5, 0. Okay? And I want you to make a connection here. What did you put in for 0 to find the y-intercept? I'm sorry, what did you put in for x? 0. X is 0. Notice what the x value is here of the y-intercept. 0. So really, when you're substituting in 0, you're just substituting in what the x value is so you can figure out the y. Now here, what is the y value is 0. Look here at the x-intercept. What's the y value? 0. So really all you're doing is choosing what the y value is already, substituting it into the expression and figuring out x. Okay? So here's your y-intercept. It has an x value of 0. Here's your x-intercept. It has a y value of 0. So there are my 2 points. So that's all I need in order to graph a line. So now I can go ahead and graph this line. Okay, so let me get my line thing out here. Where is it? Where is it? Where? All right, here it is. Okay, so now you connect those 2 points and you have your line. Whoops, I'm going to have to move that around just a little bit here. Okay, so, all right. So there's my line. Now, what I want you to do on all graphs then is you label the points you used in order to make the graph. So we use this point and we use this point, they're labeled. And then on the graph, I want you to write the equation of the line. Okay, now conventionally we usually write these up here, and this is going to be kind of hard for me because I have to write this. So, whoops, give me a moment. So this line is 5x minus 2y is equal to negative 4. Okay, so you'll write the equation of the line on the line. Okay, now I want to see that on every graph. Okay, especially if there's multiple lines on the graph, that's going to tell me which line is which line. So this is what a completed graph should look like. So make sure that you label any point you use to graph the graph, and then label the graph once it's done, so all of the information for a person who's looking at it is right here on the graph. They have the axes labeled, they have scales, they know the points that you used in order to graph them, and they know what the equation was that you began with. That is the equation of that line. So make sure you have all those things. Alright, so I covered a lot in this lesson. Make sure you rewind it if you have to. A lot of conventional things that I want you to do, and a lot of things that I want you to do when it comes to a graph. So make sure you're doing that, so that we're doing these all the same way, and that we can have a nice graph that looks nice, neat, and organized, and we can tell what all the information is just by looking at it very quickly.